Clock domain crossing. Synchronization between different clock domains. In this presentation, we will explore the challenges and solutions related to transferring signals between different clock domains in digital circuits. What is clock domain crossing? Clock domain crossing, or CDC, refers to the transfer of digital signals between circuits that operate at different clock frequencies or use asynchronous clocks. This is a common scenario in complex digital designs, but it introduces significant challenges. Why is clock domain crossing critical? There are two primary reasons why careful consideration of clock domain crossing is essential. First, metastability. This is unpredictable circuit behavior when setup or hold times are violated. Second, data corruption. This is invalid data transfer between asynchronous domains. 2 flip-flop synchronizer. The code is always flip-flop at positive edge clock destination begin sync flip-flop 1 less than or equal to async signal. Sync flip-flop 2 less than or equal to sync flip-flop 1 end. Assigned sync output is equal to sync flip-flop 2. This method uses 2 cascaded flip-flops and is the most common clock domain crossing technique. Handshake Protocol. This involves a request signal and an acknowledge signal. First, request. Sender asserts request signal with valid data. Second, acknowledge. Receiver acknowledges data reception. Asynchronous first in first out. Code wire pointer width -1:0 right pointer gray read pointer gray. Always flip-flop at positive edge right clock right pointer sync less than or equal to read pointer gray. Always flip-flop at positive edge read clock read pointer sync less than or equal to right pointer gray. This method is a buffer with independent read and write clock domains. Gray code counters. There are 2 important points to note when discussing gray code counters. First, key property. Only 1 bit changes between consecutive values. Second, clock domain crossing advantage. It prevents multiple bit transitions causing errors. Best practices for clock domain crossing. There are 2 important points to note when handling clock domain crossing. First, reset synchronization. Synchronize reset signals to avoid startup issues. Second, static timing analysis. Verify clock domain crossing constraints and timing requirements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.